Hey everybody, it's Mr. N, and this video is on how to simplify square roots, which are also known as radical expressions. All right, let's start with this first one, which is the square root of 40. Now, there are multiple ways to do this. Method one is to just make a factor tree out of this and break this down completely. So I could say that this is 2 times 20, and then break this down to be 2 times 10, and then 2 times 5. And now I find pairs, because it's a square root, so I find pairs of 2 to take out. So this is a pair of 2, so that can come out as a 2. These I don't have any pairs for, so they stay inside. So I have 2 on the outside, and on the inside I'll have this 2 and the 5 left over, which is 2 on the outside, and multiply those to get root 10 on the inside. Another method is to look for perfect squares, such as 4, 9, 16, 25, and so on. So over here, if I have the square root of 40, I can take a look at what perfect square goes into 40. The largest one is what I'm looking for, and 4 will be that largest one times 10. So now I could break this down into the square root of 4 times the square root of 10. The square root of 4 is 2, but I still have left over this root 10, which cannot be broken down, and there's my answer. Personally, I think it's quicker if you could break it down by the perfect squares. It's a little bit less work too. So take a look at the second one. We have a 3 on the outside now. All right, let's take a look at this 60. This 60 can be broken down into perfect squares. Again, it would be the 4 times 15. So this becomes 3 times the square root of 4 times the square root of 15. Square root of 4 is 2, so I end up with 3 times 2 times the root of 15, which cannot be broken down. So this is just 6 root 15. All right, so for our next example, we have 32, which again will be 16 times 2 here. That's the perfect square. And I am going to skip a step here. I'm not going to write everything out. I have this 2 on the outside. I could take the square root of 16, which is 4, and then I still have this root 2 left over because this is all underneath the square root. So this gives me 8 times the square root of 2. All right, so moving on to the next batch of problems here. Sometimes we come across really big numbers, and maybe it's harder to find a perfect square that goes into it. So we can start with something basic, and you can do your factor tree again and look for pairs. Well, I know 4 will go into it, or we can try to see if 4 goes into it, and 4 does go into it. So this ends up being 4 times 24. So these are square roots. So I could take the square root of 4, it gives me 2. And now I have left over the square root of 24. Let's break that one down again. Well, this is going to be 4 times 6, right? And you have this 2 here. So now this is 2 times the square root of 6. So I end up with 4 root 6. Now, if you would have found the largest perfect square that goes into it, you would have had the square root of 96, and you could have said 16 times 6, because that's what it can break down into, and you'll end up with 4, like that, root 6. All right, so for this next one, square root of 216, well, 36 goes into it 6 times. But suppose you didn't know that. So 36 would be 6, and then you'd have left over the square root of 6. But suppose you didn't know that. You could start from breaking it down with lower numbers. So 4, divide it out, and you'll get 4 times 54. So 4 times 54, this I could take the square root of, I have 2, and now I have left over the square root of 54, which I can break down. I know that 9 goes into this 6 times, so this will be 9 times 6 in here. I could take the square root of 9, which will give me a 3. Don't forget about this 2 on the outside there, and I have left over that square root 6. Multiply these two, 6 root 6. Again, if you can't think of the big numbers that go into it or don't want to divide out those big numbers, start with the small ones. You can always do the factor tree method as well. Taking a look at number 6 here, this we know 25 will go into it 7 times. So root 25 times root 7. So the square root of 25 is 5, and you have left over the square root of 7. All right, let's get on to these last batch of problems. So this 96 we already did, that's 16 times 6, and the square root of 16 would be 4. And we have this 10 on the outside here, and then left over square root 6, so this would be 40 root 6. And on this next one for 45, we know that 9 goes into it 5 times. So this is the square root 9, square root 5. If you want to look at it like that, I have this 5 on the outside. Square root of 9 is 3. So 5 times the 3 times the square root of 5, which is 15 root 5. And finally, the last one here. And we've got a pretty big number here. Let's see if we could break this down with perfect squares. Let's try 9 in this case. So 9 will go into it 135 times. So now I have 11 square root 9 square root 135. This is a 3, so 11 times a 3 would give me a 33, and I have left over this 135. Let's see if we could break that one down. And 9 goes into that again 15 times. Again, square root 9, square root 15. So this gives me 11 times 3 times this 3 times the square root of 15, which would give me 33 times 3, which is 99. And I cannot break down that square root of 15, so 99 root 15. So hopefully this helped with your understanding of simplifying square roots. So thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.